We have a mass moving in a circle on a table. I'm going to sketch the table quickly. The mass is at the end of a string going in a circle. And the string goes through a hole in the center of the table that's connected to another mass that's just hanging below. We're told the masses are 7 kilograms and 87 kilograms. The radius of the string, or the circle, is 2 meters. And the object is traveling at some velocity. Determine the period, the time for one revolution. Right, so we have some equations for circular motion. We have force centripetal is equal to mv squared over r. And v is equal to 2 pi r over the period. So there's our period. If I substitute this in for the v squared, I get centripetal force is equal to mass times 2 pi r period squared all over r. Then square it out. M 4 pi squared r squared over period squared. And I still have an r. So that r can cancel out with one of those. So I get centripetal force is equal to 4m pi squared r over the period squared. I know the centripetal force, it's the force that's keeping this in a circle, and it's the gravitational force on the mass that's hanging. The m in the equation, this m is the mass of the object that's going in a circle. I know pi, I know r is 2 meters, and so I can find my period. So period is equal to the square root of 4 of the circle mass, pi squared r, divided by the centripetal force, the inwards force, which is due to the tension in the string, which is due to the mass hanging at the end of that, which would be m times g, the weight of that object. So this would be m2 times g. So let's see what we get. Square root 4 times the top mass of 7 kilograms times our pi squared times our radius of 2 meters divided by our hanging mass of 87 kilograms and times our acceleration due to gravity of 9.81 meters per second squared. Plug it into the calculator. 4 times 7 times pi squared times 2 divided by the quantity of 87 times 9.81. And don't forget the square root. So I'm going to get meters to cancel here. This meters is on the top, and this is on the top of a something that's in the denominator, so it's going to be really dividing by that m. The second squared are going to swing all the way up on top, and that's the only units that are left, so it's going to be the square root of second squared. So the units work out. Okay, so about 0.8 seconds.